Okay, so this exercise says the population of Centerville with 20,000 people in 2005. The population is decreasing at a rate of 4% per year. Okay, so it's exponential decay or exponential decrease in population. Write a function to model this population. Our general formula is going to be P of t, where t equals time in years. And we have our initial population, P naught, and then it's 1 plus the growth rate here at the decay rate, but just for our general formula. So now we just got to plug in. So P of t equals the initial population, and then it's 1, and our rate, it's decreasing by 4%, so we're going to say it's 0.04. So it's 1 minus 0.04 to the t. So this is how we find our final function will be P of t equals 20,000, our initial population, times 0.96 to the t. And just one note is this is our decay factor. And this is our decay rate. So then it's asking, when will the population of Centerville fall below 10,000 people? Okay, so we're going to have to solve this using our calculator. So when we get to our calculator, we'll plug in y1, we're going to graph this 10,000. And then in y2, we're going to graph our function from above. And instead of using t on the calculator, we're going to have to use x. So we want to graph these two functions. We want to adjust our window and then find the intersection. Let's get out our calculator. Okay, so here I'm at my home screen. I'm going to go to y equals. I want to plug in 10,000. That's the population. I want to know where it ends up. And then in y2, I want to plug in my function. Make sure you get these parentheses in there. Do a little caret so it knows we want to go to the exponent. And that's where we put our variable x. So first I want to adjust my window. X, that's my time, right? So I can never be in negative time. So I'm going to say that minimum x, or the minimum time, is 0. Now x max, I'm not really sure how long it's going to take for it to decrease, but I'm just going to guess about 50 years. And then we can always adjust that afterwards. Then we go to our y's. Our y is talking about our population. So we can never have a negative population. So for our y min, we're just going to put 0. And then our y max, well, we know it started at 20,000 people, and then it started decreasing. So my max, I'm going to put it at 20,000 so we can see where our population started. So this is the window that I'm going to start with. I can always come back and adjust it. So we can see that y1 equals 10,000 is just a straight line, and then this is our decay function, our population decay function. So now we just have to find the intersection between these two lines. And the way we do that is first we hit second, from our graph hit second, and trace, and it says calc right above it. And then you can see we just want to go to the intersection, so we can hit 5. Now first curve, it's just asking where's the first curve, hit enter. Now it's on the other curve, so let's hit enter there. Those are our two curves we want to find. It's asking, do we want to guess? Yes, we want to guess the intersection point. And this is saying that x, or time, equals 16.979. So that's really close to 17. So let's just take 17 for now. So that's 17 years it takes until the population hits 10,000. Okay, so let's go back, 17. So it's asking, when will the population of Centerville fall below 10,000? Well, in 2005, we were at 20,000. So it's going to be 2005 plus 17. And that equals 2022. And that is when our population will fall below 10,000.